Last but not least, Content Provider. And then we have finished our 4 key components of an Android application. Then we know everything in an Android manifest. Amazing, right? So let's have a look into this one. And Content Provider is simply providing content, as the name suggests. In most cases, or nearly all cases, we are talking about databases. For example, the contacts in a smartphone. These are being stored in a database, and we have a Content Provider for this database, which means we can interact with them via a content URI, this one over here. The first part is simply just the prefix, which signals the smartphone or the application that we're dealing with in Content Provider. So we're having content : // This is, by the way, an excellent keyword if you reverse engineer Android applications. So if you search for this keyword, you may be able to identify those content providers pretty easily. Alright, next we've got the authority, and this is simply just a unique identifier for our content provider. So we cannot have multiple content providers with the same name. Let's imagine we're having Android contacts several times on our smartphone. We wouldn't know which one we want to call. Therefore, this name needs to be unique, and therefore a common approach is simply using the package identifier for this unique name. But it's simply just a name. It doesn't mean anything. Okay? Alright. After this one, we've got the table entry. So this is in this case the contacts table. And last but not least, we've got the /2, which means we are getting the second entry or the second row of this table. All in once, it would mean we're having the following. Here's our contacts database, and we are now selecting the second entry out of this database. So in this case, Peter Smith, phone, and the email address. Okay. The question is now, how can we interact with those content provider? Because if you remember, content providers are being excluded from intents. So we cannot simply use our intent approach like we have done this in the other 3 parts in activities, broadcast receivers, and services. Within content provider, we have to do it differently. The easiest way might be simply using the ADB shell, because beside the activity manager, we are also having a content provider in there. So we could simply use content query, and then we provide the URI of the entry we want to query. Okay, but what if we are not having access to the ADB shell? So let's say we want to write our own malicious application, like we have done this in the broadcast receiver section, to query a certain entry, to fetch these data. Well, then we have to do it in the following way. So here we are having now the contacts database, so the contacts application. And if we now want to query these contacts in our own application, we need to do this within Content Resolver. And this sounds now a little bit complex, but let's make this together. So we will master this part right now. Okay, in our own application, we need to define a Content Resolver. And this Content Resolver is now asking this content provider to provide the content to us. This is why the name perfectly fits, Content Provider. So if we are having the permissions and if this part is being exported true, then we can access this. So these are our 2 use cases which we have in all components right now. Activities, broadcast receivers, services, and also here. Okay, if the user has given the permission to our application to access these contacts database, then by asking it, the content provider is returning back a cursor to this database. And what this cursor does is, it's simply just a pointer to a database entry or maybe a database selection. For example, this one over here. So here we're having now a pointer to the first row of our database. Okay, the content provider must include the following methods, which can be now used by our application to interact with this database. So we can query, update, insert, or delete. We can also lock this down a little bit, but this is most of the time not the case. Okay, so this is the whole concept. In our own application, we are defining a content resolver. We are asking the content provider to provide an entry to the database, and then we can use the methods query, update, insert, delete to interact with this one. Alrighty? Perfect. One last note over here, if we are dealing with custom content providers, then those databases are being stored in the data directory. So we're having data, then the package identifier /db. There we will have the whole database being stored. And if this one has not been encrypted, then we can simply download it and analyze it with SQLite or SQLite browser, whatever you like. You can also choose other tools. but these are, I guess, the most common ones. Okay, and if this database is being encrypted, then we have several options. In case if it's being encrypted via an user provided data, for example, a password and key, PIN, something like this, then it will be hard. But if you're starting this application and the database is automatically being decrypted, then there needs to be all the stuff available in this application. So we need to have the algorithm, keys, certificates, whatever is required. And within the reversing section, we will have a look into an encryption algorithm, and very popular ones, which is AES. So there we will learn how to deal with things like this. Okay, so now I would suggest let's have a look into a coding example. So how does the source code regarding to a content provider looks like, that we know what we are dealing with. Alright, so on the left we've got our application, and on the right we've got our attacking application, which wants to get access to this content provider. If we ask nicely, then the content provider is returning this cursor and we can interact with this one. Okay, here we are now having the query method of this content provider, and we can see it's returning our cursor, alright, but within the query we've got now a lots of parameters. We've got URI, we've got projection, we've got selection args, and we've got sort order. So 1, 2, 3, 4, 5 parameters are in this query method. Oh well, so this sounds like an complex method. And indeed, it might be, but this one comes down to a single SQL syntax, which is super amazing. So all these 5 parameters are being transformed into an SQL statement, like this one over here. So we are having select projection, our second parameter. So this is our selection argument. From table name, this is our URI, where selection equals selection args. Both parameters are 3 and 4 are given over here, ordered by sort order. So all these parameters are being transformed into an SQL statement. And if you're talking about SQL statements, there's one type of attack that immediately catches me, which is SQL injection. And indeed, this might be possible in content providers. But to be honest, it's not that dangerous like we're having this in web applications right now. Nevertheless, let's talk about it. So here we're having now the select statement. Let's insert some values into our query method and see what happens. Okay, so here we have now our query. We've got this URI, which is our content prefix, authority name, and then the table name, which is news. In this case, we can already tell we try to query the table news. Maybe we want to fetch some news of our application. So simply just like, okay, what's up to date right now? The next parameter, our projection, is our payload, and we skip this for now. So we simply just handle this as payload. And the other ones will be filled with null. So if you're taking the SQL statement from the last slide, then we are having the following. We've got select projection from URI, where selection equals selection args, order by sort order. Let's insert all those null values because these will be irrelevant in our syntax. Alright, we are getting the following. Select projection from URI, and now we are having where null equals null, order by null. So everything after from URI is irrelevant. Okay, let's simplify this statement. This means we would get the following. Select projection from URI. So far so good. In our case right now, we are fetching news information. For example, some headlines, dates, timestamps, things like this. So now let's see how we can turn this one into a different query based on an SQL injection. Within an SQL injection, an attacker is able to insert own SQL code into an existing query and transform this into a completely new one. Let's say instead of the news, we want to access the user table regarding to usernames and passwords. How can we do this? Well, all we need to do is inserting the following payload. If we are inserting the following payload, our SQL syntax will transform into the following. Select asterisk from user semicolon, and those dash dash will make a comment out of everything which is following. So we are simply just saying everything behind this dash dash is a comment, and we end our SQL syntax exactly over here, which means instead of querying the news, we are now querying the users table. And yeah, in this case, we would fetch all this information. First name, last name, password, and email. Alright, sounds absolutely ridiculous, right? Yes, and it is. but there's a little bit of a downside. To be honest, I haven't encountered an SQL injection within a content provider which was really exploitable. Why? Because most of the time the developer is giving you access to the database anyway. So if we get access to the news table, then we might have also access to the users table. It's pretty unlikely and super rare that developers are locking tables like this down. So therefore, if you would have critical data, they might be stored into two different completely separated databases. And having an SQL injection in the laying database doesn't provide us any further information. Okay? Nevertheless, it's definitely something we should check out. Okay, to sum this up, if you want to attack a content provider, we need to make sure that we're having the permissions. I mean, regarding to system permissions, okay, we can ask the user to give this. In case of custom permissions, we can include this into our own application, if it's not being protection level signature. Okay? All right. Beside this, we also need to make sure that the content provider is being exported. I mean, here we are not having intent filters, we are only having exported equals true, because content providers are not being invoked via intents. If we want to interact with a content provider in our own application, we have to define a content resolver and ask the content provider to give us the content. If this is the case, then most of the time we get access to the whole database, which makes SQL injections possible, but most of the time not that useful for us because we can query those information anyway. Developers are separating these critical databases and do not provide us access to this. But nevertheless, these are all things we have to check if we are dealing with a content provider. Okay, besides interacting with databases, content provider can be also used in combination with files. So we can read and write to a file, and this gives us new attack vectors, which is pretty amazing for the attacker and a little bit unfortunate for the developer. So these vulnerabilities can be a huge threat to the application, and they still exist in common applications nowadays. So Google is of course aware of this and also of the threat of this vulnerability, and Google will deny the upload to the Play Store for those type of applications. So it might get less relevant in the future, but let's imagine how many apps we've got out there right now, and this might also take a while until Google is addressing this globally. Beside the Play Store, I mean, there also exist a lot of other stores, and they might not check those applications for this type of vulnerability, which means it can be still a threat also in the future. Let's imagine you've got some mobile application on a vehicle or within your IoT system or whatever else. So these applications might not be downloaded from the official store, they might have custom stores, and therefore this type of vulnerability, I guess it won't be fixed within the next 3-5 years right now. Okay, so now we know there could be a huge vulnerability in the interaction with files, and I would suggest let's find it out. Okay, here we have a music application which defines the following content provider. We can see it is exported, which makes it possible to interact with it from a third-party application. In our case, we are having our own application on the right. Okay, now let's assume we are having the following use case. The music application takes a file from our own application and starts playing it. Therefore, within the interaction of the content provider, we are providing an URI, which is addressing our file in the following scheme: content://authority/filename. The music application is resolving this URI and accessing the file, and in this case, for example, playing it. Okay, so far everything seems to be fine, right? Well, not at all. Let's see it through the eyes of an attacker. If we can determine the file name, why not choosing a file from the internal directory of this application? So the protected context directory of this app. We're talking about the data directory. Do you still remember our alarm application with the pin XML file in the shared preferences? Of course you do. And you know what? We can now make the application opening this file for us. So we can simply provide this in the following way. So content://our authority and then /file. And now the file is simply just a path traversal which goes back one directory, entering the shared preferences and opening the pin XML. Depending on the code, the application is displaying this content or it's returning this content back to our own application, which would be even more amazing for an attacker right now, because this would be exploitable remotely. So we could use this content scheme to access every file in the protected data directory of this application. Amazing, right? Absolutely. So how all of this works, we will find out in the next couple of videos. So within the first one, we will perform our SQL injection. And in the second one, we will have a look into path traversal vulnerability, accessing those files. And we will also have a look into a real-world example. So in 2020, Trend Micro did analyze a cardio application, and they identified exactly this type of vulnerability in there. I guess the data which was accessible was not that sensitive, but of course, this depends from application to application. Alrighty? Okay, so I guess we have seen everything in the theory right now, and yeah, let's exercise this a little bit. Let's find out how to exploit these content provider. So therefore, I'm looking forward to see you in the next video.